In order to graph a linear inequality, the first thing we need to do is we need to get the equation in the form of y equals. So in this one here, the first thing I'm going to do is I'm going to take away a 5x from both sides. So now I've got a negative 2y is less than or equal to negative 5x plus 10. Now, in order to get the y by itself, I need to divide everything by negative 2. But in an inequality, when I divide by a negative, I need to flip my sign over. So I get y is greater than or equal to 5 over 2x minus 5. Now I've got this in a form y equals mx plus b. So I know my slope is going to be 5 over 2, and I know my y-intercept is going to be negative 5. So I'm going to start my graph at negative 5. 1, 2, 3, 4, 5. So my y-intercept is negative 5. Because my slope is 5 over 2, and I'm going to go up 5 over 2, up 5 over 2, and I have my inequality as an greater than or equal to. So because it's or equal to, I'm going to connect my dots with a solid line. So there's my line. Now I'm going to have to shade. I'm going to decide which side of my inequality to shade on. And the way I'm going to do that is I'm going to select a test point. Now I'm selecting my test point to be the point 0, 0, because it's very easy to calculate. So if I put it into my original equation, 5 times 0 minus 2 times 0 is less than or equal to 10, I get that 0 is less than or equal to 10. Now that's a true statement. 0 is less than 10. So I'm going to need to shade in the side that includes the 0. So what I'm going to do is everything on this side is going to become shaded in. So an inequality represents an area of a graph and not a specific line or a specific function. So what that means is every single point that's in this shaded area is going to satisfy the equation 5x minus 2y is less than 10. So if I picked any point in this area, here, or here, or here, and substituted the x and the y value into this equation, so if I substituted x is 1, y is 7, into this equation, it would in fact give me a value of 10, less than 10. Here's another example. This one's already in a y equals mx plus b form, so it's going to become easy to calculate, or to graph. So I'm going to start at positive 5 because that's my y-intercept. My slope is negative 3, so I'm going to go down 3 and then over 1. And I could do it again to get a more accurate line. Now in this case, my equation is not equal to the line. It's only less than the line. So we represent this by, instead of drawing a solid line, we're going to draw a dashed or a dotted line. And again, I'm going to select my test point. Because it's not on the line, I'm going to use 0, 0 again. You can't pick test points that are along the line. That's not going to help you. You need to pick a point that's completely in one side or the other. So 0, 0 works again. So I get 0 is less than negative 3 times 0 plus 5. 0 is less than 5. Again, that's a true statement. So I am going to color in or shade everything that includes the 0. So if your statement is true, you're going to shade in the equation or the side that includes that point. If the equation turns out not to be true, so if you put in the point and it doesn't work, it's not true, you're going to shade in the other side of that equation. So if I put it in and it said 5 is less than 0, which is obviously false, I would have shaded in the other side of my equation. But in this case it worked, it was true, so I shaded in the side that included my test point.